Probability is an important part of the AP exam, with the AP framework calling probability a tool used for anticipating what the distribution of data should look like under a given model. We can use probability to help us make confidence intervals and perform Z and T tests. Outside the classroom, probability is necessary in order to make informed decisions and understand the world around us. With that, let's jump into how to interpret probability. So the book definition of probability is a proportion of times an outcome would occur in a very long series of repetitions, and this value is between 0 and 1. Eventually, when we look to a long-run relative frequency, which is doing the same event over again, we can see that the probability of an event is the number of desired outcomes over the number of possible outcomes. So let's look at this example with dice. The probability of rolling a 2 on one die is 1 over 6. Since there is one desirable outcome, a 2 over 6 possible outcomes. After many rolls, we'd expect a 2 to show up 1/6 of the time. The law of large numbers, when calculating probability, says that chance behavior has a predictable pattern in the long run. If you flip a fair coin, as I did in a simulation which I graphed here, you may start off with more heads than tails in the first 10 flips. But if you continue flipping, the percentages of tails and heads flipped come closer to its expected value, 50-50. The point is, probability focuses on long-time frequency, not what happens in the short run. Now let's go into basic probability rules and terminology. We've talked about events a little bit, and it's defined as any collection of outcomes from the same chance process. Here are the 5 rules of probability. 1. As we said before, the probability of an event must be between 0 and 1. 2. All possible outcomes together must have probabilities that add to 1. 3, and we went over this one, the probability of an event occurring is the number of corresponding outcomes over the number of possible outcomes. 4, the complement of an event is the probability that the event doesn't occur, and it's equal to 1 minus the probability that it does occur. For example, unemployment would be the complement of employment. If the unemployment rate is 5%, then the probability that someone is unemployed is 5%, and then the probability that someone is employed is 95%. 5. If two events have no outcomes in common, they are mutually exclusive, also known as disjoint, like rolling a 1 and a 2 on a die at the same time. If two events are mutually exclusive, the probability that one or the other occurs is the sum of their individual probabilities. So the probability of rolling a 1 or a 2 is 1 over 6 plus 1 over 6, which is equal to 1 over 3.
So here's some probability notation. For OR probability, we use the union symbol that looks like a tiny U. For AND probability, we use the intersection symbol that looks like an upside down U. We just discussed the complement symbol, which has a superscript C, and finally the conditional probability symbol is a vertical bar, which we will discuss later. The first simple math rule we're going to cover is going to be the addition rule. Essentially, the probability that one event or another occurs will be the addition of their individual probabilities, and then subtracting the probability that both events happen. If the events are independent, the addition essentially becomes just the addition of the two probabilities. This formula is on the formula sheet. The second math rule we're going to cover is going to be the multiplication rule. The probability that two events occur will be the probability of event A occurring multiplied by the probability that event B occurs given that A occurs. If the events are independent, PB given A just becomes PB. This isn't on the formula sheet, but should be easy to memorize. Conditional probability is the chance that one event will happen given that another event has happened. We just dealt with this in the multiplication rule. It's denoted as P vertical bar B, or A given B. This is on the formula sheet. Independence means that the two outcomes have no effect on each other. If event C's outcome has no effect on event D, then the two events are independent. This is different than mutually exclusive, however. If two events are mutually exclusive, that means if event A occurs, event B cannot occur. For example, you can't be both employed and unemployed. Before we move on to diagrams, a few quick AP reminders. Always show work, even if the problem is just a quick multiplication of two numbers, or else you won't get credit. Also, make sure you're multiplying the right numbers into your calculator when you're doing these simple calculations. So a Venn diagram shows the possibilities of two events happening or not happening. In this simple diagram, area W is the probability that A happens but not B, area X is the probability that event B happens but not A, area Y is the probability that both events happen, and area Z is the probability that neither event happens. So the probability of A happening will be the sum of W and Y, and the probability of B happening will be the sum of Y and X. Venn diagrams allow you to more easily visualize OR and AND probabilities for two events, but they can be limiting since they only allow for two events. Here we have a two-way table, and the table organizes probabilities for two categorical variables. The advantage of using a two-way table or over a Venn diagram is that you can have more than two outcomes per event. This makes it easy to see conditional probabilities. To find the total probability for an event happening, you have to sum up the column or row. For example, P of A is equal to Y plus W in this example. A tree diagram shows the probabilities through branches that show the probabilities after each event occurs. The advantage of using a tree diagram is that you can calculate probabilities when you have 3 or more events, while for the other two diagrams you can only have 2 events. Tree diagrams are useful to determine the probabilities of certain outcomes while organizing your work well. Thanks for listening to our presentation.